a lab on the design. Let's go from the beginning. Let's take it from the where we're looking at this simulation where you are to design something for an assembly line. So suitability of a production line for the grouping and packaging of cans. So as a mechatronic engineer, this is what you're supposed to know. So following the mechanics study, a carbonated beverage company has learned that many customers are interested in purchasing their canned beverages in packages of 12 units in precision of 2 rows by Z columns. What number of columns? Therefore, they decided to take one of their production line and adapt it to suit this process. You have been hired to design and implement a circuit that lets you count and group canned beverages as specified. So what are we going to be looking at? This is your virtual assembly line industry, and here you see here is the dashboard where you look at which we can open and close. This is how the dashboard works. So we can off it or we can on it, or we make a programming. So we have to adjust the settings so we can do that. But let's look at other things first before we can go into that area. And this is the power source, power on, and the output. But now we have to just toggle it off or toggle it on, whichever way we're looking at. So we say, okay, let's go. So now the whole laboratory thing is, how do we get to the point where we say we want to just look at this? These are power inputs that you must turn on. It has to do with chips, chip left and chip right, and this is the dashboard that you must configure. But we have to go back and look at it again and see what we're configuring, so we know what we're doing. And the instruction, this is a calculator. This is a virtual lab where you have the procedure. Here is where we have the situation. Here is the procedure, and here is the question you have to know how to solve. 2 raised by n minus 1 equals to maximum number of maximum counter numbers, where n is taken as the number of bits of the counter. That is, if we only use 2 bits counter, the maximum number of counts will be 3. But if we are using whatever number we're looking at, let's say we're using 4 bits counter. It will be 2 raised by 4 minus 1 gives you what you need to use. That's the equation. So every time you want to do, like now, according to the institution, they say they dedicated a particular row. They have a package of 12 units of 2 rows in Z, but they dedicated to use one particular assembly line to solve this problem. So what should you do? The procedure is here. These are the things that virtually, whatever you see here is a simulation, but it is real in real life. A conveyor belt for a can drink, a metal platform, hydraulic cylinders, photoelectric sensors, a limit switch center, a control panel with space for 1 touch screen, universal printed circuit PCB with necessary counters 2, a DC source 1 and a keypad 1. And how does the design go? You are, as the mechanical engineer, you have to go and design and implement the counter. And if you have nothing about logic gate and sensors, you cannot know how to do counters. But we're going to show you how it is done when you have your live practical. And this is, go to the control panel, do all this stuff you see here. Come again, come to the PCB, do all this stuff, the circuit diagram, do all this. And note this, that the screen is located on the circuit with the inputs and the output necessary to design the counter. In such a way, look at C1 and C2 will deliver a 5-volt signal when they detect an object, allowing the counter to be changed. Pin 1 and pin 2 assign the output of the Boolean equation. It entered, and the pins named A and D are the inputs of the binary count given by the counter. These are all done. So if you're not good in binary and Boolean designs and equation, then you can't solve this. You cannot do this virtual lab, but you can be trained to do it. Then look at the startup. When you are completely sure of the correct operation of your counters, press the green button on the panel keeper to start the line. Note that once the line is started, you will not be able to make any changes, and you have to start again if you want to stop the line from. So you have to press the red button. What do you mean by that? When we come to this dashboard here, this green button means once I start it, but since I've not put the finger, once I start it, I can't stop it until the line changes. So the conveyor belt all will move from here to here, and like I come down here and get this point, all are programmed until I say stop. this is how this lab works. So let us go back and click it and restart again, cancel. Now to go more about the info, we look at the data you have to enter, your row count, your column count, and the report being verified and everything you have to do. Now you have a calculator here on your own. You don't have to use calculator. You can do all mathematics at 8 times 6 equals, gives you the answer right here in the virtual lab. You can go here for more questions, and you can write your notes and print them out for yourself as PDF. All these are done in this virtual lab, but we're not going to do this for you until you access the class and come for the training. That's what we're going to do for you.